Whom do many call the father of modern physics? Why, James Clerk Maxwell, of course. Maxwell's importance in the history of scientific thought is comparable to Einstein's, whom he inspired, and to Newton's, whose influence he curtailed. Much of our technological developments today have been derived from Maxwell's discoveries, and many future scientists were influenced by him. James Clerk Maxwell was born on June 13th in 1831 in Edinburgh, Scotland. He was the only child of John Clerk, a town lawyer. His early education was given by his mother, and even as a child, James proved to have an exceptional mind. His memory was excellent, and he even memorized all of Psalm 119, the longest psalm and chapter in the Bible. By the age of 8, he began to conduct his own simple scientific experiments, such as observing the life cycle of a frog or observing the phases of the moon. James's mother was a great influence on him, and he was taught by her that there was a complete harmony between science and God's teachings. Maxwell would carry her teachings throughout his life and would give generous amounts of both his time and money towards his faith. Unfortunately, his mother died when he was only 8, and so Maxwell was taught by a tutor following. Maxwell's family moved about, but James soon returned to his birth town to attend Edinburgh Academy. There, he published his first scientific paper, a mathematical analysis involving the ellipse, when he was only 15. He continued his education at the universities of Edinburgh, and where he published 2 more scientific papers, and later enrolled at Cambridge University. 4 years later, Maxwell graduated with his first-class honors in mathematics. By 1856, Maxwell had already become the professor of physics at Maxwell College in Aberdeen, Scotland. In 1858, Maxwell married Catherine Mary Dewar, the daughter of the principal of the same college. From there, he moved to King's College in London, and then, 1871, to Cambridge, where he became the first professor of experimental physics of the university. There, he directed the brand-new Cavendish Laboratory, which he helped create. The Cavendish Laboratory would become a center renowned for significant advances in physics with time. Unfortunately, a short 8 years later, 1879, Maxwell died of abdominal cancer at the age of 48, but his work would live on. So what did Maxwell do exactly? Lots of things. One of Maxwell's first major contributions to science was the study of Saturn, while he was enrolled at Cambridge. At the time, there was much debate of the makeup of Saturn's rings, but Maxwell mathematically showed that the stability of the rings could be only reached if they consisted of numerous small, solid particles, as opposed to liquid or gas. This is the explanation that is still accepted today, and Maxwell was awarded a prestigious prize for his research. Next, Maxwell worked on molecules of gases in rapid motion. He analyzed the particles statistically and created the Maxwell-Boltzmann kinetic theory of gases. This theory showed that temperatures and heat were caused strictly by molecular movement. It went beyond just heat moving from hot to cold, to molecules at high temperature having a high probability of moving towards those at low temperatures. Maxwell created a better theory for the basis of thermodynamics and created the new subject of statistical physics. Maxwell's most important achievement to many was his extension and mathematical formulation of Faraday's theories of electricity and magnetic lines of force. Maxwell showed that a few relatively simple equations could express the behavior of electric and magnetic fields and their linked nature. He showed changing electrical fields produce changing magnetic fields, and vice versa. His equations, known as Maxwell's equations, are one of the greatest achievements of 19th century physics. In future research, Maxwell also calculated that the speed of the transmission of an electromagnetic field is approximately equal to the speed of light. He therefore proposed that light was an electromagnetic wave, exerting pressure and carrying momentum. Because charges can oscillate with any frequency, Maxwell concluded that visible light only formed a small part of the entire spectrum possible of electromagnetic radiation. Maxwell proposed the basis of all electromagnetic waves, and in 1888, Heinrich Hertz produced the first man-made radio waves, confirming Maxwell's theories of other electromagnetic waves with different wavelengths. X-rays, radios, televisions, radar, and satellite communications all have their origins with Maxwell's theory. Even Einstein's theory of relativity was influenced by it, and quantum physics. With the development of electromagnetic theory, Maxwell integrated all previously seeming unrelated observations regarding electricity, magnetism, and optics into one theory. Another area of research Maxwell contributed to was color blindness, and his work was awarded the Rumford Medal by the Royal Society of London. Maxwell took 3 different images, switching from green, red, and blue filters, and then recombined them back together. From this research, Maxwell continued to be one of the first scientists to demonstrate color photography, which created the basis of photography today. A few more of Maxwell's achievements include showing how to calculate stress in framed arches and suspension bridges, and working with others to define most of the electrical units in use today. One of the final areas Maxwell made an impact on in the scientific community was the creation of the universe. Maxwell strongly opposed Darwin's theory of evolution, which was popular during his time. From his mother's teaching, Maxwell believed both a creator and science created life. Theories of evolution contradicted scientific evidence, and Maxwell even mathematically disproved the hypothesis of Laplace, a French atheist, that the solar system began as a cloud of gas, which contracted over millions of years to produce planets in 1796. Laplace claimed that there is no need for a creator, but Maxwell showed mathematically no such process could occur without help. Maxwell worked to show all that science and the Bible were not only compatible but should be linked together. Overall, Maxwell made an incredible impact on science, and particularly physics. His research, especially on electromagnetics, is the origin and inspiration of many scientists and technologies we have today. His work has even inspired some to show praise through poetry. He played with colors blue and green, and red enhanced by dubious sheen, and took the earliest color photo, as good as only Blake or Giotto. He analyzed the rings of Saturn, resolving their striated pattern, predicting wheel their composition by calculus and long division.